Howdy everybody. This week I didn't really have a video or a demo planned for you, so I thought I'd talk to you about an idea rather than get into another protocol or another kind of packet or something of that sort. And so what I'm after today is something called flows. So first of all, we have the question is, what is a flow? What constitutes a flow? But I want to talk about that in the context, or in the larger context, of design. Okay, so when we look at routers and hosts that have ARP tables or routing tables, we look at source address tables. All of these are tables that refer to where things are connected, how to forward packets. But in the larger context of things, we're actually interested in something called flows. Now, a flow is a collection of packets that are all heading between the same source to a destination. So it's a collection of packets, right? Think of them as same source and destination IP address. All right, so that's one thing. So now we got a couple of other ideas. One might be a macro flow versus a micro flow, a large flow versus a small flow, a long-term flow versus a short-term flow. And that's the kind of thing that we actually start to worry about when we start thinking about design and how to put things together and where things are going to be located. Okay, so things that we don't care about. Onesie twosies. So we don't really care about DNS traffic, for example. We don't care a whole lot about ARP traffic, because by the time you figure out that a flow existed, it's gone again. But if we start to see that we've got lots and lots of long-term series of packets running between A and B, then now it's time to start thinking about how best to handle that particular flow. So that ought to make sense to you. When you start to see lots and lots of traffic between a client and a server, maybe, and that traffic flows over a particular set of links, and now we have to start thinking about provisioning those links or provisioning that pathway in an appropriate fashion. Okay, so if we push that a little bit, and we start to think about, well, I've got this server, and there are going to be people connecting to this particular server, and therefore generating flows. What's the best way to optimize that connection? And where's the best place to put that server? Okay, so this has ramifications for almost everything that we do. Not only where do we physically locate the box, or where do we put the virtual machine, but what about VLANs? VLANs have a structure, and one of the most important ideas in building your VLAN boundaries is understanding who is talking to who. It doesn't make any sense to build VLAN boundaries or your IP-based subnets, your IP-based addressing, without understanding first where the data is flowing and who's going to talk to who. So that becomes a really, really important idea to us. So this idea of flows and understanding the nature of the traffic on your network, and that's another really important idea. All right, so another important thing to realize when we're talking about flows, where traffic is going and where is it coming from, is whether or not the traffic is on-site versus off-site. It used to be that we would say that traffic was, we had an 80-20 rule. So that meant that 80% of your traffic was local, and 20% of your traffic went somewhere else, either off the subnet, off-site, or something of that sort. Well, of course, today we say that that's sort of on its head, where most of our traffic goes off-site, and a small percentage of it is local. So if you think about that for a sec, you go, well, I work at a particular place, and I've got printers that are local, I've got maybe some servers that I'm hitting, but then we've got cloud data shares, maybe our applications are out there, maybe I actually have a development environment that's out there. So those are all indications that we've got our traffic that's going elsewhere. So we've got not an 80-20 rule, but a 20-80 rule. And so understanding that flow of traffic is really, really important to us, because we would design our network differently in case A than we would in case B. All right, so now we live in this fascinating modern age of software-defined networking. And so now we have this discussion of north-south flows and east-west flows. So this also is very, very important when you start thinking about virtualization environments and how you're going to build, say, your own data centers, where you're going to locate things. So generally speaking, we say that a north-south flow is traffic that is flowing from a client to a server, or a user to a service of some kind. East-west flows are flows that are between objects or between services. So for example, if I as a user talk to an application, talk to a server of some kind, let's say that I'm going to log into my bank, then that is a north-south flow. But the bank then talks to a database, or there's a lookup of some kind that's done. Well, those are east-west. Those are two things that are talking to each other that don't have anything to do with a user involved. Okay, so generally, again, when you're interfacing with the users, you've got end nodes talking to services. We call that north-south, and then east-west flows are services, or machine-to-machine a lot of times. Now, sometimes this gets modified a little bit depending on the conversation that you're having. So sometimes we'll call north-south flows things that need to be routed on up through the application layer. So we go from a MAC address to an IP address to a socket connection and then to an application. So you can think of it that way as well. You can also think of east-west flows as on the same layer. So if I can talk to somebody on my same network, I might be talking about traffic that's traversing the same layer. So very horizontal, very flat sort of topology sort of decision. Okay? So that's another way to think about it. So I just wanted to reach out to you a little bit to talk about the idea of flows, because I did a thing on software-defined networking, and flows are a really big part of software-defined networking. In fact, we start to talk about flow tables. When you deal with MPLS, we deal with flow labels and things of that sort. So flows are an idea pushing a little beyond maybe the normal ideas that we have regarding routing and switching. So it's an important sort of idea behind some of the ideas that you're used to dealing with. Again, generally, east-west is going to be service to service, machine to machine, and then user to service or client server is going to be north-south. Well, I think that'll about do it. I hope this fulfills that gap in your life that just said I had to watch a networking video. And I'll see you guys next time. Remember, it's networking. You can do this.